Hello class, this is a video tutorial on direct proportion and inverse proportion. And in this video, we're going to be looking at merely recognizing whether a scenario is directly proportionate or inverse proportionate. And I'm going to show you just a quick way to figure out which is which. So the first thing that we need to learn is just some quick definitions. So two quantities are in direct proportion if an increase in one quantity causes a proportional increase in the other. I wrote here, or a decrease, because we can switch out increase with decrease in both of them. So it can either be if an increase in one quantity causes a proportional increase in the other, or it can be if a decrease in one quantity causes a proportional decrease in the other. And here are just three quick examples of each. So here they are. So the cost to hire builders for a job, the cost of meat at a store and the weight of the meat bought, and the distance traveled and the time spent on a train. So let's do some quick calculations just to sort of get our head around this. So let's say that the cost of one builder, so let's make B for let's get a different color here. Let's make it that one builder, let's just say it cost $200 for the day. Okay, so one builder costs $200 for the day. So if we increase one, so let's get this up until two builders. If you notice that from 1 to 2, it's not a +1 increase, although you can look at it that, but it's a times 2 increase. We have doubled the number of builders. But because that it costs $200 for one builder, then it must certainly cost $400 for two builders. So, and that's what it means by a proportional increase. So if it's increased by a proportion of 2, this has also increased by a multiple of 2. And that's what it means as a proportional increase. We can keep going like this. So if I had 7 builders, well then, looking at our unit, if one builder costs 200, so from 1 to get to 7, it has multiplied by 7, which means from 200, it'll also multiply by the same proportion by 7 as well. 200 times 7 is $1,400. So in this scenario, if you wanted 7 builders, it'll cost $1,400. Let's take a look at a few more examples here. The cost of meat at a store and the weight of the meat bought. So I'm pretty sure you've seen a few prices of meat. Let's say it cost $5.50 for every 1 kilogram. Well, if I wanted to buy, let's say, for all time's sake, 4 kilograms. Well, that has an increase of, a multiple of 4, which means that this will also increase by that multiple of 4. That would be $22, I believe. Yes, $22. It'll cost me $22. And so I'm pretty sure you're getting the idea of what it means to be directly proportionate. So if this increases by a multiple of 2, so will the other quantity. So we can say that the cost for a job and the number of builders are in direct proportion. And in this one, the cost of meat and the weight of meat are in direct proportion. And once again here, the distance traveled and the time spent on a train. So let's say, for example, that on a train, it's assuming that the train doesn't stop and it's always moving at the same speed at all times. Let's say the train travels, so let's say it's traveling at 120 kilometers per hour. Okay, it may not look like it, but there's a direct proportion here. So the way you can look at it, so since we've seen 120 kilometers per hour, you can also look at this as 120 kilometers is equal to 1 hour. I'll make this 1 so you can see it. So the time spent on the train is 1 hour, and in 1 hour they would have traveled 120 kilometers. So if we went for 2 hours, well, then we would have traveled 240 kilometers. And once again, you can see that direct proportion. It has multiplied by 2 here and has also multiplied by 2 on the other quantity. So this is direct proportion. Now, for inverse proportion, it is very similar. However, if you read very carefully, it reads, if an increase in one value causes a proportional decrease in the other. Okay, so take a look. They are the opposite. So if you increase one, the other will decrease proportionally. Or you can switch these around. If a decrease in one causes a proportional increase in the other. So let's take a look at this one, a few examples. So here's the first example. The number of builders and the time it takes to build a house. So let's say, for example, that two builders can finish one house in 100 days, for example. They're really fast builders. Now, if we get twice as many builders, so 4 builders now think very carefully here. Will this also increase by the same amount? So if you take a look, this would have multiplied by 2. Now, assuming all the builders can finish the job, can all work at the same rate, can you see that if we double the number of builders, the amount of work needed to be done will be actually halved. So when this increases by a multiple of 2, this will decrease proportionally. It will decrease by the inverse. So the opposite. So if this multiplies by 2, this will divide by 2. It will halve. And it sort of makes sense, doesn't it? If you have 2 builders, 100 days, 4 builders, it'll halve the work, so there'll only be 50 days. And another way you can look at this as well is if there is only 1 builder. So if we went from 2 to 1 builder, we have actually halved, so we've divided by 2. This will effectively actually make the amount of work double. There'll be only 1 builder can do it in 200 days because it is in inverse proportion to each other. So since this has divided by 2, the amount of work will multiply by 2. So let's just take a quick look at these other examples. So the number of people who win a jackpot and the prize money of the jackpot. So let's say if 1 person wins, so 1 winner, And if the jackpot was, say, 2,000 people, $2,000, sorry. But let's say coincidentally, if two people win, two winners, they both can't win $2,000 each, right? Because there's only $2,000 to be won. So the only fair thing to do is actually divide the 2,000 into the two people that win. So each person will win only $1,000. So that there is, as you can see, since this multiplies by 2, the other value would have divided by 2. That's the inverse proportion. And the last one we have here is the speed of a rocket and the time it takes to travel to the moon. So let's say the rocket is traveling at 100 kilometers per hour, and it takes, I don't know, 80 days. It takes 80 days to get to the moon. I'm just making this up. If they triple their speed, so 3, actually no, that's not a good number. Let's say they multiply by 4. They quadruple their speed. They go crazy fast. Kilometers per hour. So they went from 100 to 400 kilometers per hour. That's a multiple of 4. Well, since they go faster, it won't take them longer to get there. It'll actually decrease the amount of time it takes to get there by the inverse proportion. He would actually divide by 4. 80 divided by 4 is actually 20 days. So that concludes the video on inverse and direct proportion, and I hope from this you can recognize different scenarios as being direct proportion or inverse proportion. Best of luck.